Question 6. Zoom to 100%. That's a bit big. Right, okay, let's shrink that down. Oh, I can't. I'll just zoom out. Never mind. Forget it. Distance particular car can travel a journey starting with a full tank of fuel was investigated. From a full tank of fuel, 40 litres remained after the car had travelled 80 kilometres. 25 litres remained after the car had travelled 200 kilometres. Using a linear model. It's in bold. Yeah, so we can model this using a straight line graph. V being the volume of fuel remaining in the car's tank, D being the distance it has travelled. So when D is 80, we know V is 40. There's 40 litres left when we've gone 80 kilometres. And as we drive more to a distance of 200, that reduces to 25 litres. Let's just join those up. Okay, so we can see with this linear model that there's going to be a y-intercept of this straight line, and that would tell us how much fuel was in the tank when we hadn't gone anywhere yet. So in other words, at the start of the journey, how much fuel was in the tank. So that's going to be useful later. But for now, we just want to find the equation of this straight line graph. Very simple thing to do because we have two coordinates on the graph. We can use our equation for a straight line graph, which is y minus y1 equals mx minus x1. And we can find m by changing y over changing x, or y2 minus y1 over x2 minus x1, if you prefer. But we can just do our good old-fashioned gradient triangle. Yeah, so y has gone from 40 to 25. It's gone down by 15. X has gone from 80 to 200. It's gone up by 120. So the gradient m is minus 15 over 120, which simplifies to minus 1/8. So plug that into this equation and use either one of those coordinates that we've got. So y minus 40 equals minus 1/8 x minus 80. Y minus 40 equals minus 1/8 x plus 10, minus an eighth times minus 80, positive 10. And if we want it then in the form y equals mx plus c, then we just need to move that 40 over. So y equals minus 1/8 x plus 50. Now I've done this in terms of y and x. Of course our model isn't in terms of y and x, so really all the way through this I should have been doing it in terms of v and d. But it doesn't matter, I'm just more used to writing this equation in terms of y and x. So we'll just make sure that now in this final step we put back v and d as the parameters of our model, minus 1/8 d plus 50. Simple. Okay. So we've done part A, find the equation linking V and D. Part B, find the initial volume of fuel that was in the tank. So we know that that's the y-intercept of the graph. If we haven't set off yet, then that's the initial volume of fuel in the graph. From our equation, we can see our y-intercept is 50. So we've got 50 litres. The car continued until it ran out of fuel. So this line will continue until it hits the x-axis, at which point the volume of fuel in the tank remaining is 0. We're not going to solve this by extrapolating, but just to visualize, at some point we're going to keep losing fuel until the point that we have none left, and there is some distance on the x-axis that we will have travelled at that point. So we're finding the x-intercept of this straight line graph. So just substitute 0 for v into your equation. 0 equals minus 1/8 d plus 50, which means that 1/8 d equals 50 if we add on 1/8 d to both sides. Multiply both sides by 8 and we get 400 kilometers. So that's the distance the car would have travelled, 400 kilometers. Lastly, in fact, the car travelled 320 kilometers on this journey. Evaluate the model in light of this information. Well, the model predicts it's very small, it's going to zoom down a bit, hasn't it? Let's go large. The model predicts we will run out of fuel after 400 kilometers, but in reality the car ran out after 320 kilometers. This means it is not a very reliable model. We managed 20% less distance than the model suggested that we were going to. So it's not a very good predictor. I mean, if you were using that, if your fuel gauge had stopped working and you were using this model to predict when you would run out, so you know when to fill up again, you're going to run into trouble, I think. It's not a very reliable model. And that's it, done. All right.